Thanks, Amy. Hi, everyone. My name is Chris Henrick. I write code for mostly front-end stuff with interactive maps and data viz for GreenInfo network. And I also teach a class on data viz with D3 at the University of California at Berkeley. I'm talking about a project today I've worked on over the past year, which started as a freelance project on a shoestring budget and now has continued with my work at GreenInfo called NYC Crash Mapper. So a little bit about where I work, GreenInfo Network. We're a nonprofit GIS and cartography shop located in Oakland, California. We do web mapping and web interactives as well. And we have a mission statement of doing work in the public interest. So that means we are primarily client-driven. We do a lot of work for organizations doing work in environmental conservation, outdoor recreation, public lands, public health, and some government work funded by the USGS. NYC Crash Mapper is a web application that allows people to explore vehicle collision data in New York City. And in order to create it, we had to wrangle over 1 million records of tabular data, open data on vehicle collisions published by the New York City Police Department from 2011 to present. And just to back up and talk about what open data is and in the context of open data in this project. Open data is open, but not always usable, of good quality, or easy to download. And I think the biggest, perhaps, reason that is this concept of dog fooding, or this term called eating your own dog food, which comes out of tech, where when you're creating a product and you're marketing it, the idea is that you're using your own products in your day-to-day operations so that you can empathize with users more, so that you can understand what bugs people might encounter, and it helps you build a better product. But sadly, a lot of open data portals aren't actually used by people in government. And so that leaves very little incentive for data QA and improvement. And so that leads to some problems with the data that we're using. So 14% of all crashes aren't even geocoded. Thanks, NYPD. 35% of all crashes are missing really valuable information like the on-street name, the cross-street name, a borough name, and contributing factors like what led to the crash. That number gets up to 85% if you count unspecified as an invalid contributing factor, which appears a lot in the data. And there's also this problem of a one-size-fits-all with open data portals. And so open data portals can't work well for every type of data and every possible use case. So with NYC Crash Mapper, we had to, like I said, wrangle over 1 million rows of data. That averages out to be about 17,500 crashes per month in the city. That's over the last 3 years. And our goal really is to make the vehicle collision data more open or more accessible to people. Our primary audience are transportation safety advocates in New York City, so people working on the ground to get traffic safety improvements in their neighborhoods or localities. And the work was funded by a nonprofit called CheckPeds in Hell's Kitchen in Manhattan with a general grant from CARTO. And so CARTO is the backend that powers the app, so it stores the data, renders tiles, and we query data for the UI. So some of the features of the app, when it loads, it displays the most previous month of crash data. And then it allows people to drill down and filter. So you can filter by a geographic area, such as your borough, your community board, the city council district you're in, something called a neighborhood tabulation area, which is based on census tracts, the NYPD, zip codes, but we're removing those because they're very problematic. So this is the community board for North Brooklyn over the past year, from March of 2017 to March 2016. And then crashes in the same geographic area get aggregated, so the circle size represents a larger number of crashes in that area. They're color-coded by no injury or fatality, injury, and fatality. And then you can also filter by those crash types. So here we've selected all injuries across pedestrian, cyclist, and motorist. The app also allows you to draw a custom area and filter data that way. So here you can filter data along a corridor if you'd like, and see what the general stats are below. The app allows you to download data, so as CSV, GeoJSON shapefile, or KML. And that was a really important thing because if you try to download 1.2 millions of records from the Open Data Portal, it's like good luck. And then you can share the URL. So the URLs are stateful, so whatever filters you have applied in the map are stored as query parameters in the URL. So that way, if you want to look at a really particular view of the data, you can email that link to somebody else and they'll get the exact same view. And so some upcoming improvements and features, because the first round was not perfect. One thing we're obviously dealing with is lots and lots of overlapping points. And we were trying to solve that by using larger circle sizes when the points were on the same area, but that gets really difficult because a lot of times the crashes might as well be in the same location, but they're off by slightly precise decimal degrees. So another way we're approaching looking at that is by using hex bins at lower to mid zooms. And then also some non-geographic ways of looking at the data. So one thing people are curious about is how does the crashes in their area trend? So this is pedestrian injuries for a city council district, number 5, compared to all of New York City. So the city council y-axis on the left, the city-wide axis on the right, and to just kind of give people an idea of okay, well, how is my locality comparing to the citywide or maybe borough-wide trend? And then maybe comparing the data to different, apples to apples, like City Council 4 to City Council 51, or maybe against 2 different time periods. And this is just kind of an experiment using a kind of dot grid chart where each dot that's filled in is representing a fatality. Each dot that is not filled in is representing an injury across different person types, such as pedestrian, cyclist, and motorist. And this is a way we're just trying to humanize the data more, because it is a really serious subject that a lot of people get very seriously injured, and we don't just want to create a bunch of bar charts and pie charts and line charts. So that's really all I have to share. Feel free to reach out to me, ask me questions later. My handle on Twitter is Chris L. Henrick, and you can email me at chrishenrick@gmail.com. Thanks.